Okay, so can you hear me? Hello? Hello, can you hear me?
Yes, sir.
Okay. So we are waiting some 1 or 2 minutes for joining all of the participants. Then we will start our for the today's session. Okay, so we will start and also get the start the recording. Anyone can miss the class, they can also cover the part for hearing the recording. Okay, so let's go. Okay, so basically today is our third number of class. Okay, so basically it's totally 7 days. So today is our third number of class. So we will try to complete all of the course content within the 7 days. And in the meantime, you face any problem regarding any issue, you can just contact with me. I hope you can easily got the solution and also get all of the things. Okay, so let's go. We will start our today's session. So I simply share my screen. Okay, so now can you see my screen? Okay, can you see my screen now?
Yes.
Okay.
Yes.
Okay, so let's go. So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis from beginners to advanced level. So basically today is our third number of class, and today we will try to discuss all of those course content. So because we will try to discuss about our course content for the third test. So I think some person also join. Okay, so today is our third number of days. Basically today I will try to discuss about that how we can easily filtering and displaying the satellite image, mainly Sentinel-2. Okay, so previous class I also try to discuss about the Landsat image, and today's class I also try to discuss about the Sentinel, how we can easily filtering and displaying the satellite image for Sentinel, and using the Sentinel image how you can easily monitor the NDWI. Okay, using the same process you can also monitor the NDWI. Using the same process you can also monitor the EVI or any types of other index. Okay, same process you can easily apply. Then we try to discuss about that how we can easily make the NDVI, NDWI. So this type of indices time series chart, different time period, how we can easily do that. We also try to discuss about that. Then we also try to discuss about that how we can easily export the any shape file from the Google Earth Engine platform, and how to calculating any indices from the satellite images. So basically for calculating the different types of indices has the different types of method. In this part I will try to discuss all of those method so that you are able to do calculate any types of indices, any types of equation. It can be big equation, it can be a small equation, NDVI, EVI, SAVI index, MNDWI. So any types of equation, how we can easily calculating, any types of indices, how we can easily calculating. So I also try to discuss about that. And then how to add the gradient legend on your Google Earth Engine map. Okay, we also try to discuss about that. And we also try to discuss about the Landsat based temperature monitoring. Basically two types of data set I also try to discuss, Landsat and MODIS. Today I try to show you that MODIS data set, how you can easily work with the modis and also make the LST map, also make the LST time series chart. And next further class we'll also try to discuss about the Landsat. How can you use the Landsat image and then make the land surface temperature map. Okay. Then we also try to discuss about that calculating the NDWI from the modis and Landsat data. Okay. Then okay, so these are today's course content. We try to complete it all of the things. Okay, so let's go. So first of all, filtering and visualizing the satellite images in Google Earth Engine platform. So previous class we also try to discuss about the sum factor when you want to filtering the satellite image. It's different sum factor. Okay, so in this time we are also applying the same factor, but we need to some change about their properties. We need to some change about their function. Okay, we also try to use here the different function for filtering the satellite image, mainly Sentinel. You can easily apply the same process also Landsat. There is no problem. So mainly, first of all, we need to select our region. Okay, first of all, you need to select your region when you want to filtering the Landsat or Sentinel both of image. First of all, you need to select the region. Suppose I can select my region is the Dhaka city. I need the Sentinel-2 satellite image for the Dhaka city. So this is my region and this is my one factor. Another factor is that I want to need only for those image, which image will be not more than 1% cloud cover. So this is my another factor. Okay. And third factor is that a specific time period. Suppose I need this image for the wet season. For the Dhaka city year of 2017, I want to need the image for the wet season. I need the image for the rainy season. Okay. So any time period. So basically when you want to filtering any satellite image, it's different some factor. This three factor mainly: region, image metadata, and a specific time period. Using this process, we can filtering the Landsat as well as also filtering the Sentinel-2 satellite imagery. Okay, so let's go about that. We can try to discuss about that. I simply open my code editor and try to show you the practical example. Then it's also better. So for that, I simply open a code editor. Okay, I open a new code editor. Then it's also better. Okay, so I simply open a new code editor and try to show you the practical example. Then you can easily get the idea how you can easily do that. Okay, so first of all, I simply search the browse data catalog and then simply go to this Sentinel and then simply find out the Sentinel-2 satellite imagery and work with that. Or if you want, simply search here in the top of the code editor. Suppose simply search here the Sentinel-2. Okay. Now I can get all of those Sentinel-2 suggested images in the list in here. So in this time, I want to use here the Sentinel multispectral instrument, this image. And here I can get all of the information about this image, all of the things I can got in here. Also check the time period availability. Okay. Also dataset provider is that European Union, Copernicus, ESA. Okay. And also you can see bands, all of the band we can easily access from here. Also get the image properties, mainly cloud pixel percentage, cloud coverage assessment. Okay, this type of image properties we can easily get. Lot of image properties in here. So mainly in this time we are using for the cloud pixel percentage. Suppose for the Dhaka city region I want to need only for those images, which image will be not more than 1% cloud cover. Okay, this type of image I want to need. Also, okay, so I simply import that. You can see the import, simply import. Okay, so now my image collection is imported in my code editor and it's showing the default variable name. Okay, you can use any variable name, you can write any types of variable name. It's totally depend on you. Suppose in this time I simply put this name Sentinel-2. Okay, so I put this name Sentinel-2 and then I also need to import my boundary. Okay, which boundary I want to need this Sentinel imagery, I need to import my boundary. So in this time, suppose I simply import the boundary of Dhaka city. So I simply import this Dhaka city boundary and give this variable name. Table is the default variable name. I put the name as RY. Okay, put the name is the RY. So in this time, I want to filtering this Sentinel imagery according to my region, according to my image specific metadata, according to the image specific time period. Okay, so in this time, I want to display the result for the two time periods. Suppose I want to need the Sentinel-2 satellite image for the Dhaka city, dry season period as well as also wet season period. Okay. Then for the dry season, I want to monitor the NDWI, and also for the wet season or rainy season, also monitor the NDWI. Okay, then you also try to check there what's the difference, how when the NDWI is the high, when the NDWI is the low. We try to show you that using the time series chart. Okay, so let's go about this. So first of all, I simply take a variable. So I put the variable name, suppose you can use any variable name. I put the name, suppose image dry. Okay, image dry, I take this variable name. In this variable I store the image for the dry season. Okay, now I need to call my image full collection. Okay, this is my full image collection. Sentinel-2, it stored this variable is the full image collection. So I simply paste here. Okay, in this time, this image is the full image collection. Basically this variable stored the full image collection for the whole world. But in this time, I don't need for the whole world. I need only for my region of interest of Dhaka city. Okay, so for that I simply use a function filter bounce function. Okay, so in this time what happened when I want to use the filter bounce function? This is the full image collection. Okay, when I want to use the filter bounce function, it intersecting the full image collection for my region of interest. Then I can got only for those images which images are available for my region. Okay, and you can check the geometry. Geometry is that ROI. Okay, I simply put the ROI, and then if you want, you can also use here the, if you want, you can also take the new variable, or if you want, you can simply use here the dot notation. Previous class I also try to discuss about that. Use the dot notation, and then you can simply put the next function. Suppose I want to need the image a specific time period, so put here this, suppose filter date function. So I put here the specific time period, suppose year of 2020 dry season for the Bangladesh. Okay, so for that I simply put this time period year of 2020 1st January from put the time for the perspective of Bangladesh. I put this dry season period, suppose 2020 April, suppose 30. Okay, so I simply put this dry season period time perspective of Bangladesh, put this time period look like this. Okay, and now I want to use here a function, this function called the filter metadata. Okay, we already know about the function. Basically this function filtering our specific metadata. Okay, image specific metadata, and we can get here the name, operator, and value. Okay, so in this time name is the image properties name. So here you can check the image properties name okay, you can easily get from here. You can see image properties name, suppose cloud pixel per sentence. Simply copy that. I want to need only for the image which image will be not more than 1% cloud cover. So simply put here. Okay, and then put here this operator. I simply put this operator is that less than, and set the value for 1. I need only for this image which image will be not more than 1% cloud cover. I use the filter metadata. Okay, so this is the filtering process. Basically in this time it's mentioned the question about the where the place you want to need the satellite images. It mentioned the question about the when you want to need this satellite image, and it mentioned that how. Okay, so how mean that what the properties you want to need. Okay, so in this time we can filtering according to the where, when, how. Okay, so now in this time, instead of the filter metadata, we can also use the another function. Okay, this function called the sort function instead of the filter metadata function. So in this time, suppose I want to use another function, this function called the sort function. Basically in this time I will try to give you all of those function knowledge, so that you can use the your different time which is the better for you, you can use that. Okay, so in this time instead of the filter metadata function, we can also use here the another function. It's called the sort function. Okay, sort, basically sort is filtering the image properties for a specific characteristics or a specific image properties. So in this time I sort according to the cloud pixel per sentence. Simply copy and paste here, and then when I want to use a boolean operator in here, suppose use here the false, it means that in this time all of those cloudy pixel value I remove. False, basically it give the remove. Okay, basically this function in this time I did not specific anything about the 1%, 2%, 3%. When you want to filtering according to the 1% cloud cover, 2% cloud cover, 10% cloud cover, then we can use here the filter metadata function. But in this time, I want to use here the short function. So that's why in this time I can get the result. All of this pixel value, which cloudy pixel value, which are available in my region, all of the things will be removed. Not only for the 1, 2, 3 like this, less than 1% in like this. All of this pixel value will be removed. Okay. So in this time, the short, when I want to use the short function, it also increasing the image number. Okay. But when I want to use the filter metadata, we did not get the more image. Okay. When I want to use the short function, it also increasing my image number. Okay. So in this time, I want to use the short according to the filter metadata. If you want, you can also use the filter metadata. There is no problem. Mainly filter data we are using when you want to constant value. Suppose I want to need the image less than 1%. I want to need the image less than 5%. I want to need the image less than 10%. Then we are using at the filter metadata. But in this time, when I want to use the short function, I remove all of this cloud pixel. Overall, all of this cloud pixel. Okay. When I want to false function, it remove all of those cloud pixel. Okay. So now I want to create the composite. So if you want, you can create the median composite. Then all of those image pixel will create the median. If you want, you can also use the mean. If you want, you can also use at the mode. Okay. So in this time, I want to create the mosaic composite. So mosaic, all of those images create one composite in this time. So in this time, I want to apply the mosaic. So for that, I simply use a function such as mosaic. You can see use at the mosaic. Okay. And after that, I simply use at the cliff function with my region of interest is that RY. Okay. So now, okay, I take a question, just a minute. Okay, so basically, there are a lot of suppose top of atmospheric, harmonized, level 1C, level 2, lot of image source we can easily get from here in Google Earth Engine platform, and different image has the use for the different tasks. Suppose different image we can easily use for the different tasks. Suppose mainly when you want to make the land cover classification map, then it's also better using the surface reflectance. When you want to use the monitor the different types of indices, it also used for the top of atmospheric. Okay, so lot of image collection we are using for the different tasks. Okay, it's also some variation. Suppose when you want to make the land cover, it's also better for the SR image. Okay, so this type of we can easily do for that. Okay, and also you can also get the more information about their description. Just you can check it from the image information. Then, but filtering process is the same. When you want to filter the surface reflectance, same. When you want to filter the top of atmospheric, same. Harmonized, same. All of this filtering process is the same. Okay, so now let's check about our satellite image. So I simply add a layer. So use add this map dot add layer and call my object name is that image. Right. Okay, click to the run. It showing a layer, but it did not focus my region. So I simply use a function map dot center object for center focusing of my region is that ROI. Suppose put here the 8 and click to the run. Okay, so now it display the result. Okay, we can get this image look like this black color default because we did not add the visualization. So in this time we can get the image look like this. Okay, so now I want to add here the visualization parameter using the different types of band combination. So let's go. I simply click on here, and then here I can get the suppose band 4, red, then green and blue color, and also increasing the state reflectance value 98% for the better looking. So then apply. So in this time, this visual will be set with my image. You can see it loaded. Okay, we can get the image, and this visualization is only available for this code editor. This visualization I also need to import in my code editor. So click on here. You can see it will be added a new line of code. Simply copy this variable name and paste after the object name. You can see basically dry season we can get the very clear satellite images. There is no cloud, there is no haze, So in this time we try to display the result for the wet season. Okay, so we are using the same code. Okay, so and try to show you that what is the condition of the satellite image for the rainy season or wet season. So for that I can simply copy the same code from here. I can simply copy the same code and then paste here. Okay, and then I simply change the variable name. Suppose image wait season or wait, then all of the thing will be same. Just I simply change the time period. Okay, so in this time I simply put this time period such as 2020 1st June, from I put this time such as suppose October. Okay, October 30 or October 31. Okay, just I put this time period look like this. Okay, for the rainy season or dry season. So in this time all of the thing will be same. Just I simply copy and paste. Okay, then okay, I simply remove that. First of all I will load the layer, then add the visualization. So now you can see it will be added a new layer, and now I can got this image for this time period, rainy season time period. Yeah, please, any question you can ask me. Yeah, any question? Hello.
Sir, actually, I want is the use of those forward slash.
What?
You're keeping the forward slashes. What is the use of those slashes?
Okay, so basically this slash is the meaning the comment. Okay, so basically you can see this is the comment. Okay, when you want to define the comment, then we need to either two forward slash. Comment is the give the information about your code. Okay, and this line of when I want to use this two forward slash, this line is not executed, it will be not running. So here you can say use the two forward slash, so that's why it will be it's this code is not running. Okay, so two forward slash is not part of the code, it's give the information about your code. Okay, suppose in this time filter bounds, so mainly we are using for the filter bounds for the where suppose this image I need for this region, so that's why I need to use the filter bounds. So anyone who can understand about that where I use this filter bound function, why, then they are using they see the comment about the where means that it's identify the place. And also again I put this in the filter date function, it's mainly using for the when. Okay, so when you want to filter this image for the specific time period, then I can use the filter date. Okay, also you can see how. So basically it's not a part of the code, it give the information about the code. Anything you can write, there is no problem. Suppose you can write anything, suppose then click to the run. In this time you can see there is a nothing happened, there is a no disturbedness in my code. Okay, because it's a comment I can write anything, there is a no problem. This is not the disturbedness of the code. But you can see when I remove the two forward slash, then I can get the problem. You can see it already showing this cross sign. It means that some problem on your code, it's showing the syntax error. Okay, so mainly we are when you want to define write any information about your code, then we are using here this two forward slash. Suppose this code I did not run, so then I simply use the two forward slash. Now it will be work as a comment, and this code is not working. Okay, so I hope you can got the answer. Okay,
Thank you, sir.
okay, now click to the run again. So in this time I also add the visualization of the rainy season satellite images. And add the visualization, so just click on here. So add here the suppose red, then green and blue, increase 98% and apply. So in this time we can get the image look like this. Also import this and simply copy the visualization from variable name and paste after the object name. Now click to the run, and we can also add here the layer name. Suppose I put this is the suppose wait image, and also we can also put the comment layer name such as this is the dry image. then click to the run. So now this two type of layer you can add in here, you can see. So now again, so you can get the image. In this time, we are getting the image, and this image we can get some cloud on the rainy season. You can see this is the cloud. Okay, for the rainy season, mainly we are getting the cloud in the rainy season. But dry season there is no cloud. We can get the very clear satellite images in here. So in this time, in Google Earth Engine platform has some other tool or function. Using this function, we can easily make the cloud masks and also remove all of the cloud. So further class, I also try to discuss about that, how we can easily remove this type of cloud and also make the clear satellite images and remove all of the haze. So basically, cloud is hampered your land use land cover classification map. Suppose in this time, when you want to make using this land use land cover classification map, this type of pixel will be mixing with the build up area, barren land, and destroy this land use land cover classification map. Okay. So basically, for the you can see the some research paper there all time when they are make the land use land cover classification map, they are ignoring the rainy season or ignoring the wet season. Okay, they take the image for this time when time is that only for the dry season. Okay, because in this time there is a no cloud. But in Google Earth Engine platform, we can also remove the cloud. There is a no problem. Cloud is only hampered for the land use land cover classification map, but it's not hampered when you want to work with the NDWI, NDWI, or indices. There's no problem. Okay, so in this time, we are getting the two time period images. This is the dry season image, and this is the wet season image. So in this time, I want to make the NDWI map. So I want to make the NDWI map for creating, for using the two satellite images. I want to make the NDWI map. Okay, so let's go how we can easily do that. So for that, first of all, we need to know about the equation of the NDWI. So NDWI equation is that green minus near infrared. If you want to check it from here, suppose NDWI formula for Landsat 8. So we are using here the Sentinel. So now we can see here, we can get this. This is our Sentinel-2 formula normalized difference. Okay, B3 and B8. Okay, basically this is the green and this is the near infrared band. Okay, so this is our equation for the NDWI. Okay, so in this time I use this type of equation and then try to make the NDWI. In this time there is a lot of way when you want to implement this type of equation. The lot of way we can easily do that. So in this time I want to use here the easiest way. Then also for further, I also try to show you all of those way for calculating this type of equation. I think there are the total 3 way for calculating this type of equation. So let's go. So in this time, I want to show the, suppose I want to calculate the NDWI for the dry season. So I take a variable and put the variable, suppose NDWI dry. Okay. Put this variable name is the NDWI dry. And then I simply call this image for dry image. I need to call the dry image. Okay, because I want to calculate the NDWI from the dry image. So simply call and paste here. Okay. In this time, I want to use a function. This function called the normalized difference. Okay, this is the function. So in this time, basically this is the built-in function. This function already created when you want to use the normalized difference. Okay, I simply copy the function and open in the docs tab for the documentation check. You can check. You can see basically this function argument is that band name. Okay, in this time when you want to use the function, it computed the normalized difference as a first minus second divided by first plus second. So in this time, suppose I want to put here this band, first band suppose green, second band I put here this suppose near infrared. Okay, B3 and B8. So then it can compute it as the green minus near infrared divided by green plus near infrared. So let's go. We mention this band name in here. Suppose first band, I want to put the first band is that B3. Okay, I want to put the second band is the B8. Okay, so this is my green band and this is my near infrared band. Okay, if you want to check the information about the band, you can check it from the band. You can see this is the B3 is the green and B8 is the near infrared. So I need only for the two band, B3 and B8. Okay. So here you can see I simply call my image. Okay. And this is my dry season image, and dry season image has all of the band is available. Okay. From this all of the band, I need only for the calculated the normalized difference using this band. Okay. In this time, from this image, it take the green band and near infrared band and calculate it as a green minus near infrared divided by green plus near infrared. Okay. This function mainly work like that. Okay. So I can get the image for the, and I calculated the NDWI and store it in this variable. So now let's go about the display the result. So for that I simply use at the map dot add layer and put here the NDWI try and put here. Now okay, so I can check the result and add here the visualization parameter. So you can see it added this NDWI map for the price season. Okay. So in this time, okay, so in this time I added the visualization. So for that I can simply, okay, so I simply make the dictionary in here. I put here the mean, it will be start from the -1 and also put here the max from the +1. Okay. And I want to define the color plated such as use the color plated and make the list of the color such as suppose red color, then put here this color for yellow, and also put here this color for yellow, then put here this color for suppose green, and finally water body and to display such as blue color. Okay. So basically in the NDWI, high positive value for the NDWI, high positive value it identify the water pixel. Okay. And low pixel value it identify, it can be vegetation, it can be barren, it can be rock, so this type of things. But high positive value identify the water body when you want to use at the NDWI. Okay. So now let's go check our result. We can check. Okay. So it loaded. Okay, so we can get the map look like this. Okay, so in this time we are also trying to display the map for the NDWI for the rainy season. So basically we easily understand about that for the rainy season we can got the lot of water pixel value. Okay, because in the rainy season for the rainfall happened, so that's why we can get the lot of water pixel value in this place. In this time we showing the result for the uh, dry season period. Okay, so let's go about that. We can use the same code, simply copy, just copy and then paste here and change the name, suppose NDWI wet season. Okay, and call this wet season image. So we can see this is the wet season image, simply copy and paste here. Okay, so now in this time all of them will be same. I simply copy that, simply copy and paste here, paste, and also I put the layer name, then it also better, suppose NDWI suppose dry season, and also put the another layer name, suppose NDWI wet season. So now let's check about the result about the 2 time period. Okay, so in this time we can check. Okay, in this time you can see we did not show the water pixel value clearly. It means that in this time I get put here the range, okay, -1 to +1, but all time for my region this range will be from this, it not okay. But in this time this range can be also increasing or not increasing or decreasing my NDWI pixel value within this range -1 to +1. Okay, so if you want to check for any water body, suppose this is the water body, I simply check it the pixel value from here. Here I can get the pixel value for, okay, so NDWI 0.3. Okay, also I check the another pixel value for the wet season. Can check, okay, 0.2. Okay, so in this time I want to simply put here the suppose 0.5 and then check about the result 0.5 and also put here the suppose 0.5. So I want to set this 0.5 for my visualization. Okay, so in this time I want to get all of those pixel value within this range, so let's go about the result. Get loaded all of the layer. Okay, so now you can see, now we can easily identify the water pixel value. Okay, as the blue color you can see lot of water pixel value we can got in the rainy season. Okay, and also you can see this is the dry season and also you can see this is the rainy season. Okay, so you can see this is the rainy season, lot of water pixel value increasing. Okay, but when I want to put here this dry season, you can see only we can get the some water for this Hatirjil lake and also in here or some water pixel in here. Otherwise when I want to open this NDWI for the rainy season, here you can see lot of water pixel. Okay, so now you can easily export this type of map and also work with the ArcMap software. This part I already show you that you can easily export. Suppose here you can see I already create. Okay, so this is a sub index map. So any types of map when you want to create, then you can simply export. Okay, and exporting process is the same. Okay, exporting process is the same and you can easily apply the same process and easily apply this type of map you can create using the ArcMap software. Just download the TPMs and all of the things will be same. Okay, so now anyone any question you can ask me. Yeah, please.
Yes, sir. One thing I just wanted to know. We already have seen how to calculate NDWI images using Sentinel. Now, if I need to export only the water pixels, I mean only the water pixels, I need to export from this classified imagery. So how we can export the file?
Okay, okay, so in this time we are also get the help of the max function. Okay, so in this time suppose you want to export only for this water pixel value, this water pixel value you want to export. Okay, so it also possible, we can easily do that. So okay, I'll also try to show you this part, just a minute. Okay, so in this time I want to suppose in this time we can get the average pixel value. What is that? You can see I think 0.3 or 0.5 look like this for the all of the water pixel value. Okay, so in this time we are also get the help of the ND update max NDVI. suppose in this time it's showing the result. So for that, suppose it's very important. So using this process, you can also updating the separate the vegetation, anything, any pixel value you can easily identify or easily separate, and also only for the downloaded the water pixel value. So for that, I simply take a variable. Suppose put the variable name is that suppose water. Okay, and then you can simply call. Suppose in this time this map. Okay, this map the NDWI weight map. Okay, and NDWI weight map is that. Simply copy this variable name and paste here. And then in this time you need to put your range. Okay, suppose in this time for the I want to need this pixel value less than 0.2 and greater than negative 0.1. Okay, you can put your own range which next pixel value you want to need. So in this time I simply put here the suppose LT means that less than 0.2, and also use here the another function. It's called the AND function, and I simply call this variable name. Okay, simply copy the variable name and paste here. Suppose and greater than GT greater than negative 0.1. In this time when I use this range, then get less than 0.2 and greater than 0.1, 0.1. So in this time all of those pixel value will be struck only for that. So for that, in this time I put my range. You can use any types of ratio in here, there's no problem. In this time I want to just simply take the another variable. Suppose water pixel. You can use any variable name. So then I simply call this water and paste here this variable name and use a function. It's called the update max function. So use here the update max. Okay, basically in this time which ratio I want to put in here, or which range I put in here according to this ratio or according to the range I want to update my image. Okay, so for that I simply call that variable name water, simply copy and paste here. Okay, so according to this I want to put that. Okay, as well as I can simply put another function. I just multiply with my variable name. So put here this multiply with this, simply copy the variable name and paste. Okay, so now let's check about the result. So for that I can simply check the result. Suppose I want to simply check the result using the print function. What I can check it. Suppose print, simply copy the water pixel and paste and click run. Okay, I can get only for the one image. Okay, only for the one image, -1 to +1 fault. Okay, so now let's check about the result first. We can check the result. Suppose I want to add here this map.add layer, and then simply call this variable name, paste here. Now check the result. In this time we can check the result. We can check first layer. Okay, so in this time you can see it selected this range of pixel value. Okay, greater than 0.2 and less than 0.2 and greater than -0.1. So you can see the result. Okay, so now you can simply you need to mention this range within your pixel value. Okay, then we can do that. Suppose in this time I also increasing. Okay, so I check the point value of this NDWI, so that's why we extract only for that. Suppose we can get the result for NDWI 0.3. So 0.3 is that for water body. Okay, so for that high positive value. Okay, so I simply use here the greater than suppose 0.1. Now check about that. So I use here the suppose 0.3 and then take. So you have to find out this pixel, which pixel is the almost extract all of those water pixel or all of those which you want to need. Simply select this, then it will be work. And this is the same process you can easily apply.
But how to define the range?
Okay, a range. This range is the vary from one place to another, and it's not a constant. So for that we have to check the pixel value from one or two place. Then we need to use that. Okay, when you want to selecting the specific pixel value, because in this time we can check at for this region the positive one is not available. We can get the 0.5 or 0.3 or 0.4 highest NDVI in NDWI pixel value. Okay, so it's vary from place to place.
Sure, thank you.
Okay, so using this process you can easily extract any pixel value from here. Okay, so this is the out of topic. I simply comment that. So when you want to extract any pixel, not only for that, you want to extract for the specific NDVI pixel value, then mainly we are using at the update max function. Okay, this is that, and also put our range, which range I want to need, then put that. Okay, then we can get easily extract that and easily export the, suppose you want to export the water body, exporting in the same process. Okay, so now you can see we can get the result look like this. Two type of map I can got in here. Okay, so now I want to okay, so in this time we also try to discuss about the time series chart about that. Okay, you can also apply the same process for that when you want to calculate the NDVI, same process. Okay, for the NDVI or NDWI we need to create the time series chart. Okay, in this time you can see this data set is not prepared. Okay, basically we can create the data create this type of map from the satellite image. Okay, some data set you can also check about your from your, you can see you can get the some data set is already ready made in Google Earth Engine provide. Suppose you can see modis, this data set is already ready made. Suppose NDVI, then EVI, so all of the data set already ready made. Okay, this data set is created from the modis satellite image. So in this time it work as a product. Okay, from the modis we can get the product for the LST, we can get the product for the NDVI, EVI. Okay, all of those products we can get. So basically this data set is the ready-made data set, but in this time you can see I create the NDWI map, but this data set I create from the satellite image, raw satellite image. Okay, raw satellite image I create. So basically when you want to create the time series chart using the ready-made data set and also unready-made data set, it has also some difference. Okay, so in this time I also try to show you the both of process, how you can easily create the chart for this ready-made data set, as well as how you can easily create the chart when you want to get the image from the satellite image and also make the map. So now you want to make the time series chart. Okay, so let's go about that. We try to discuss. Okay, first of all time series chart. Suppose I want to observe that time series chart about that suppose wet season image. What is the condition of the wet season and who is between this time period? You can see already defined this time period. So in this time period, when the NDWI pixel value is the high, when the NDWI pixel value is the low. So this type of calculation we try to discuss in this time using the time series chart. So for creating the time series chart, first of all, we need to create the band. Okay. So mainly when you want to create the time series chart for ready-made dataset or unready-made dataset, we have to create the band. So here you can see the ready-made dataset benefit is that suppose I want to create the LST time series chart. So here you can see they're already create the band. Okay, LST day 1 kilometer, they're already create the band. Suppose I want to create the time series chart for another dataset. Suppose okay, this dataset, you can see they're already create the band. They already create the band NDWI, EVI. So I create the NDWI time series chart. NDWI band is already available. In this time, for my image collection, there is the no band for the NDWI. Okay. So first of all, I need to create a band of NDWI. If you want to check your image, which image you want to use in here, suppose image wet season, you want to check how many band are available. You can simply print that. So print this result. Suppose image wait, simply copy and paste and then click to the run. You can check how many band are available. So console tab, it will, you can see 16 band is available. Okay, 16 band, and there is the no band about the NDWI. But when you want to create the time series chart, you must be create a band. In this time you can see this band is not available in here. So in this time, first of all, I need to create this band. Okay. For creating this band, we can simply use a function and create this band. So let's go. So first step is that create a band. When you want to work with the NDWI, then you need to create the NDWI band. In this time, I want to create the NDWI band. So let's go. I take a variable. Suppose add NDWI. You can use any variable name. There is no problem. And then you have to define the function. So use at the function keyword. Put at the function keyword. In this function keyword, I define the element. Suppose image. Okay. And put here the curly bracket. In this curly bracket, I define what I want to need. So in this